Hello, everyone. This is my attempt to provide a brief overview of the DevOps interview process from application to selection, covering all the essential DevOps tools in a single video. This section is taken from my book, Cracking the DevOps Interview. One of the reasons I wrote this book is that while there are many books available for coding interviews, there are only a few comprehensive books dedicated to DevOps interviews. Let's first start with what is DevOps. DevOps is a set of practices, philosophies, and cultural philosophies that aims to shorten the system's development life cycle and provide continuous delivery with high software quality. DevOps combines development and operations, reflecting its purpose of bringing together the software development dev and IT operations ops processes. DevOps aims to improve collaboration between development and operations teams, automate the software delivery process, and enable organizations to build, test, and release software faster and more reliably. Overview of the DevOps interview process from application to selection. The interviewing process for a DevOps position typically spans 6 to 7 rounds, beginning with the initial job application phase or when a recruiter discovers you resume on an online portal. This is followed by an email or call from the recruiter to verify your interest and availability for the specified role. The subsequent round may involve a coding assignment or an initial screening conducted by the hiring manager. Success in this phase leads to an on site interview, which is structured as follows: 1. Coding assignment. This round tests your coding skills and your ability to solve problems through programming. It's designed to assess your technical proficiency and how you approach coding challenges. 2. Linux internals. Given the central role of Linux in DevOps environments, this round delves into your understanding of Linux systems. It covers topics such as system calls, file system structure, process management, and other internal workings of Linux. 3. DevOps related questions. This segment focuses on your practical knowledge of DevOps practices, tools, and methodologies. Questions may range from continuous integration and delivery pipelines, infrastructure as code, automation, monitoring, and cloud services to how you handle specific scenarios in a DevOps context. 4. System design. Although not covered here due to abundant available resources, this round evaluates your ability to design scalable, robust, and efficient systems. It tests your architectural knowledge and capacity to design solutions that meet specific requirements. 5. HR round. The purpose of this round is to assess cultural fit. It explores your interpersonal skills, work ethic, and alignment with the company's values and culture. This round is crucial for determining how well you would integrate with the team and contribute to the company environment. You will likely be selected for the position if you successfully steer through all these stages, demonstrating both technical proficiency and a good cultural fit. Each round is designed to evaluate different aspects of your capabilities, ensuring that you are well suited for the demands of a DevOps role. Let's look at the first tool in the DevOps toolkit, Linux. What is Linux? Linux is a free and open source kernel first released by Linus Torvalds on September 17, 1991. It forms the core interface between a computer's hardware and its processes, communicating instructions to and from the central processing unit, CPU, and peripherals, and executing processes. Unlike proprietary operating systems like Windows or Mac OS, Linux is developed collaboratively under the GNU General Public License (GPL), meaning anyone can freely use, modify, and distribute it. The term Linux often refers not only to the kernel itself, but also to the wide array of Linux distributions distros that combine the Linux kernel with a selection of software packages to create complete operating systems. These distributions can vary widely in their focus and functionality, with some designed for general desktop use like Ubuntu, Fedora, and Mint, others for use on servers like CentOS, Debian, and Red Hat Enterprise Linux, and still others for specialized applications such as network security, digital forensics, and embedded systems. What to expect in the Linux interview. When interviewing for a DevOps engineer position focusing on Linux, expect questions that challenge your expertise in managing complex Linux environments, system optimization, troubleshooting, networking, security, and administration. 1. Linux system optimization. Kernel tuning. Be prepared to discuss how you've used sysctl for kernel parameter tuning to optimize system performance. Performance monitoring. Expect questions on tools like top, htop, vmstat, istat, and sar, and how you use them to identify and resolve performance bottlenecks. Resource management. Discuss strategies for managing system resources such as CPU, memory, and I/O, including cgroups and Linux OOM out-of-memory settings. 2. Advanced Linux troubleshooting. System recovery. You might be asked about times you've had to recover a Linux system from boot failures, kernel panics, or file system corruption. Log analysis. Be ready to explain how you analyze system and application logs to troubleshoot issues using tools like journalctl, dmessage, and log files in Volog. Network troubleshooting. Discuss your approach to diagnosing network issues on Linux, including using IP, netstat, SS, TCPDump, and traceroute. 3. Networking and security. Firewall and packet filtering. Expect to answer questions about configuring and managing firewalls using IP tables, NF tables, or firewall. SSH hardening. Discuss methods to secure SSH, such as key-based authentication, changing default ports, and configuring SSHD options. See Linux and AppArmor. You should explain how you've used these security modules to enforce access controls and protect against vulnerabilities. 4. Linux administration and automation. Scripting and automation. Be prepared to discuss how you've automated routine tasks and deployments using shell scripts, Python, or other scripting languages. Package management. Expect questions on managing software and dependencies using package managers, apt, yum, DNF, and custom repository setups for package distribution. Service management. Discuss your experience managing services and daemons, including using systemd and initd scripts and creating custom service units for application management. 5. Storage and file systems. LVM and RAID. Be ready to explain how you've configured and managed Logical Volume Manager LVM and RAID arrays for performance and redundancy. Network file systems. Discuss your experience setting up and managing network file systems like NFS or Samba for shared storage solutions. Backup and recovery. Questions may cover backup strategies, tools like rsync, tar, dump, and restore, and disaster recovery planning. Let's look at the next tool in chain, Git. What is Git? Git is a distributed version control system designed to handle everything from small to very large projects with speed and efficiency. Created by Linus Torvalds in 2005 for the development of the Linux kernel, Git has since become the most widely adopted version control system for software development and other version control tasks. It allows multiple developers to work together on a project, tracking and merging file changes and ensuring that conflicts between concurrent modifications can be resolved. Git operates on the principle of repositories, which are complete databases of a project's history. It tracks changes to a project over time by taking snapshots of the files, which are then committed to the repository. Developers can branch off the main project, creating a branch, work independently, and then merge their changes back into the main project main master branch, facilitating collaborative work without overriding others' contributions. Git's architecture and features have led to its adoption by countless individuals, projects, and organizations worldwide, making it a critical tool for modern software development. What to expect in the Git interview. When preparing for an interview focusing on Git, it's essential to cover both the practical usage of Git commands and a deep understanding of its principles, workflows, and problem-solving techniques. Here's an in-depth look at the areas you should be familiar with. 1. Basic Git operations. Initialization and cloning. Understand how to create a new Git repository Git init and clone an existing repository Git clone. Basic commands. Be fluent in Git add, Git commit, Git push, Git pull, and Git fetch. Know how to check the status of your repository with Git status and view the commit history using Git log. 2. Branching and merging. Branch management. Know how to create, list, rename, and delete branches Git branch, Git checkout, Git switch, Git branch D. Merging. Understand how to merge branches Git merge and resolve merge conflicts. Be familiar with different merging strategies and when to use them. Rebasing. Explain the concept of rebasing Git rebase, its advantages, and how it differs from merging. Know how to solve conflicts during a rebase. 3. Advanced Git features. Stashing. Understand how to use Git stash to save uncommitted changes temporarily. Cherry picking. Be able to cherry pick commits Git cherry pick from one branch to another and understand the implications. Tagging. Know how to create tags Git tag for marking specific points in history as important, typically for release versions. 4. Undoing changes. Reverting commits. Understand how to revert changes using git revert and the difference between git revert and git reset. Resetting. Know how to use git reset to undo commits, including the differences among soft, mixed, and hard options. Reflog. Be familiar with git reflog to recover lost commits or to undo complex changes in the repository history. 5. Git internals. The .git directory. Understand the structure and contents of the .git directory, including what information is stored in objects, refs, the index, and the head. Git objects. Have a good grasp of Git objects blobs, trees, commits, and tags, and how Git uses them to represent repository history. The 3 states. Be clear on the concept of the working directory, the staging area index, and the repository itself in Git's architecture. 6. Workflow strategies. Feature branch workflow. Understand how to use feature branches for development and how they fit into the development lifecycle. Git flow. Be familiar with the Git flow workflow, its branch structure, and where it's most applicable. Forking workflow. Know how the forking workflow operates, especially in open source projects, including how to manage upstream repositories and pull requests. Chunk-based development. Understand the principles behind chunk-based development and how it encourages shorter-lived branches and more frequent integration. 7. Collaboration and best practices. Pull requests. Be able to explain how to create and manage pull requests, review code, and merge changes in platforms like GitHub, GitLab, or Bitbucket. Code review practices. Discuss the importance of code reviews in a collaborative development environment and how Git facilitates this process. Commit messages. Understand the importance of meaningful commit messages and how to write them effectively. 8. Problem solving with Git. Handling large files. Know about Git LFS large file storage and when to use it. Reducing repository size. Be prepared to discuss strategies for reducing repository size, including Git GC, removing old files, and dealing with binary files. Recovering lost work. Understand how to recover lost commits or branches using commands like git reflog and git fsck. 9. Security in Git. Signing commits. Be aware of how to sign commits with GPG to verify authorship. Managing credentials. Understand secure ways to manage credentials, including credential caching and SSH keys. 10. Tooling and integration. Git hooks. Know about Git hooks and how they can automate certain tasks within the Git workflow. Integration with CI/CD. Understand how Git integrates with CI/CD pipelines, triggering builds, tests, and deployments based on Git actions. Preparing for a Git-focused interview requires a balance between understanding the command line usage and the theoretical underpinnings of Git. Be ready with examples from your experience of applying Git to solve problems, collaborate with teams, or improve the development workflow. Demonstrating a deep understanding of Git's capabilities and best practices will set you apart in a senior DevOps engineer role. Let's look at the next tool, Docker. What is Docker? Docker is an open source platform that automates application deployment, scaling, and management within containers. Containers allow a developer to package an application with all its parts, such as libraries and other dependencies, and ship it out as one package. This ensures that the application will run on any other Linux machine regardless of any customized settings that the machine might have that could differ from the machine used for writing and testing the code. Docker uses a client-server architecture with a Docker daemon running on the host machine and the client talking to the daemon to manage containers. Docker images, which are lightweight, standalone, executable software packages that include everything needed to run an application code, runtime, libraries, environment variables, and config files, are used to create Docker containers. These images are stored in Docker registries such as Docker Hub, allowing users to share and distribute containerized applications more efficiently. Overall, Docker simplifies the development lifecycle by managing the intricacies of the environment where the applications run, making development, testing, and deployment processes more predictable and efficient. What to expect in the Docker interview? Preparing for an advanced Docker interview requires a deep understanding of containerization principles, architecture, and practical experience with Docker environments. You'll need to demonstrate proficiency in creating efficient, secure, and scalable Docker solutions. 1. Docker fundamentals. Containerization versus virtualization. Understand container differences, benefits, and limitations compared to traditional virtual machines. Docker architecture. Be familiar with the Docker daemon, Docker client, images, containers, Docker hub, and Dockerfile. Understand how these components interact within the Docker ecosystem. 2. Docker images and containers. Dockerfile best practices. Know how to write efficient Docker files, including minimizing layer size, ordering instructions for cache optimization, and using multi-stage builds to reduce final image size. Image management. Understand how to manage Docker images, including tagging, pushing to and pulling from registries, and optimizing image storage and layers. Container lifecycle management. Be adept at starting, stopping, pausing, and removing containers, as well as managing container states and logs. 3. Docker networking. Networking models. Understand Docker's networking capabilities, including bridge, host, overlay, and MAC VLAN networks. Be able to configure and troubleshoot container networking. Port mapping and communication. Know how to expose container ports to the host and enable communication between containers across different networks. 4. Docker storage and volumes. Persistent storage. Understand the importance of persistent storage for stateful applications and how to implement it using Docker volumes and bind mounts. Storage drivers. Be familiar with different storage drivers Docker supports and how to choose the right one based on performance and compatibility requirements. 5. Docker Compose. Orchestration with Docker Compose. Know how to use Docker Compose to define and run multi-container Docker applications. Understand the structure and options available in a Docker Compose YAML file. Best practices. Discuss best practices for Docker Compose, including managing environment-specific configurations and secrets. 6. Docker cluster management. Understand how to set up and manage a Docker Swarm cluster for container orchestration. Services and stacks. Be able to deploy and manage services in a swarm, scale them up or down, and use stacks to manage multi-service applications. 6. Security in Docker. Container security. Know the security implications of containerization and Docker. Understand how to secure Docker containers and images, including using non-root users, scanning images for vulnerabilities, and using Docker Bench for security. Network security. Discuss strategies for securing container networks and implementing network policies. 7. Performance optimization. Monitoring and logging. Be familiar with tools and strategies for monitoring Docker containers and hosts, including logging best practices and using Docker native tools or third-party solutions. Resource limits. Understand how to limit container resources using CPU and memory constraints to ensure optimal container performance and resource sharing. 8. CI/CD integration. Docker and CI/CD pipelines. Discuss how Docker can be integrated into CI/CD pipelines for building, testing, and deploying applications. Be familiar with tools and platforms that offer native Docker support. 9. Advanced topics and trends. Kubernetes versus Docker Swarm. Understand the differences and use cases for Kubernetes and Docker Swarm for container orchestration. Emerging technologies. Stay informed about emerging technologies and trends in the Docker and container ecosystem, such as Containered and BuildKit. In addition to mastering these topics, be prepared to discuss real-world scenarios where you've applied Docker to solve complex problems, optimize workflows, or improve system architecture. Demonstrating a blend of theoretical knowledge and practical experience will be key to standing out in an advanced Docker interview. Let's focus on next tool, Kubernetes. What is Kubernetes? Kubernetes, often abbreviated as K8s, is an open source platform designed to automate application container deployment, scaling, and operation. Google originally developed it, and the Cloud Native Computing Foundation maintains it. Kubernetes aims to facilitate both declarative configuration and automation. It has a large, rapidly evolving ecosystem with widely available services, support, and tools. What to expect in the Kubernetes interview. Preparing for a Kubernetes interview, especially at a senior level, requires a deep understanding of its architecture, features, and operational challenges. You need to be well versed in designing, deploying, managing, and optimizing Kubernetes clusters. 1. Kubernetes architecture and components. Cluster architecture. Understand the components of a Kubernetes cluster, including nodes, pods, services, and the control plane API server, scheduler, controller manager, etc. Networking model. Be able to explain how networking works in Kubernetes, including pod networking, service discovery, and network policies. 2. Pods and controllers. Pod lifecycle and management. Know how pods are created, scheduled, managed, and terminated. Understand pod lifecycle hooks and how to use them. Controllers and operators. Be familiar with different types of controllers, replica sets, deployments, stateful sets, daemon sets, jobs, cron jobs, and their use cases. Kubernetes operators are and how they extend Kubernetes capabilities. 3. Services, load balancing, and networking. Service types. Understand the differences between cluster IP, node port, load balancer, and external name services and when to use each. Ingress and egress. Be able to configure and manage ingress controllers and resources for managing external access to services. Understand network policies for controlling pod-to-pod communication. 4. Storage in Kubernetes. Persistent volumes PV and persistent volume claims PVC. Understand how to manage storage with PV and PVC, including dynamic provisioning and storage classes. Stateful applications. Discuss strategies for running stateful applications in Kubernetes, including using stateful sets and managing states with persistent storage. 5. Configuration and secret management. Config maps and secrets. Know how to use config maps and secrets to manage configuration and sensitive data in Kubernetes applications. Environment variables and volume mounts. Understand how to inject configuration into pods using environment variables and volume mounts. 6. Security in Kubernetes. Authentication and authorization. Be familiar with Kubernetes security mechanisms, including RBAC, service accounts, and network policies. Security context and policies. Understand how to use security context to set permissions and privileges at the pod and container levels. 7. Monitoring and logging. Observability. Know how to implement monitoring and logging in Kubernetes, including using tools like Prometheus, Grafana, and Fluent or Elasticsearch for logging. Health checks. Understand how to configure liveness and readiness probes for monitoring container health and managing container lifecycle. 8. Cluster maintenance and troubleshooting. Upgrades and rollbacks. Be able to perform cluster upgrades and rollbacks safely. Understand the strategies for updating applications and Kubernetes components. Troubleshooting. Have strategies for diagnosing and resolving common issues with pods, services, networking, and storage. Know how to use tools and logs for troubleshooting. 9. Advanced scheduling. Custom schedulers. Understand the scenarios where you might need a custom scheduler and how to implement one. Affinity and anti-affinity. Be familiar with pod affinity and anti-affinity rules for controlling pod placement relative to other pods. 10 Kubernetes best practices and patterns. Design patterns. Discuss common Kubernetes patterns such as microservices, sidecars, init containers, and operators. Performance optimization. Understand how to optimize cluster performance, including resource requests and limits, horizontal pod autoscaling, and efficient use of network and storage resources. 11. CI/CD with Kubernetes. Continuous deployment. Know how to integrate Kubernetes with CI/CD pipelines for automated deployment and rollback of applications. Be familiar with tools and practices for achieving continuous deployment to Kubernetes. 12. Cloud native technologies. Service mesh. Understand the role of service meshes like Istio and Linkerd in managing service to service communication, security, and observability in Kubernetes environments. Cloud providers. Be aware of how Kubernetes integrates with cloud services, including managed Kubernetes services like GKE, EKS, and AKS. To excel in a Kubernetes interview, it's crucial to understand these concepts and have practical experience deploying and managing applications in Kubernetes. Be prepared to discuss real-world scenarios, challenges you faced, and how you've leveraged Kubernetes to build scalable, resilient, and secure applications. Demonstrating your ability to apply Kubernetes best practices and solve complex problems will set you apart as an advanced Kubernetes user. Let's focus on the next tool, Terraform. What is Terraform? Terraform is an open source infrastructure as code software tool created by HashiCorp. It allows users to define and provision infrastructure using a high-level configuration language known as HashiCorp Configuration Language (HCL) or optionally JSON-YAML. By allowing infrastructure to be expressed as code, Terraform enables infrastructure management practices that are consistent, reproducible, and more efficient than traditional approaches. What to expect in the Terraform interview? For senior candidates, interviews focusing on Terraform often explore the candidate's depth of understanding regarding infrastructure as code (ISC) concepts, proficiency with Terraform syntax and features, and ability to design, manage, and troubleshoot infrastructure deployments. These discussions can cover a wide range of basic to advanced topics to gauge a candidate's expertise and experience with Terraform and its application in real-world scenarios. Basic understanding and setup. Candidates might be asked about Terraform's foundational principles, including its role in automating infrastructure deployment through code. Questions could cover Terraform's basic commands in it: plan, apply, destroy, the purpose of the Terraform state file, and how Terraform compares to other ISC tools like AWS CloudFormation or Ansible. Interviewers might also inquire about setting up and configuring Terraform, understanding provider plugins, and the significance of versioning in Terraform files. Terraform syntax and constructs. An in-depth discussion on Terraform's syntax and constructs helps interviewers assess a candidate's capability to write and interpret Terraform configurations. This includes understanding resources, data sources, variables, outputs, and modules. Candidates may be asked to explain how they would structure Terraform code for modularity and reusability, or how they manage variables for different environments, example staging versus production. State management and operations. Interviews often delve into Terraform state management, exploring topics like state locking, remote state storage example, using a WSS3 with state locking via DynamoDB, and strategies for state backup and restoration. Questions may also cover Terraform's execution plan, understanding how Terraform creates a plan, and the importance of reviewing this plan before applying changes. Advanced features and best practices. Candidates might be asked about advanced Terraform features, such as dynamic blocks, conditional expressions, and loop constructs example count for each. Discussions also cover best practices for writing maintainable and scalable Terraform code, including the use of workspaces for managing different environments, leveraging modules from the Terraform registry, and adhering to naming and formatting conventions. Complex scenarios and troubleshooting. To assess problem-solving skills, interviews can present complex scenarios that require designing multi-tier applications or integrating Terraform with continuous integration, continuous deployment (CID) pipelines. Candidates might be asked how they approach debugging Terraform errors, managing dependencies between resources, or performing blue-green deployments with minimal downtime. Security and compliance. Given the critical importance of security and compliance, candidates may be questioned on how they use Terraform to enforce security best practices, manage sensitive data example using Terraform Vault Provider, and ensure compliance with organizational policies and industry standards. By exploring these areas, interviews aim to uncover a candidate's technical proficiency with Terraform, their approach to infrastructure management, and their ability to leverage Terraform's capabilities to build, change, and version infrastructure safely and efficiently. The discussions help identify candidates who are skilled in using Terraform and understand the best practices and strategies for successful infrastructure as code implementations. The next topic is shell scripting. What is shell scripting? Shell scripting is a method for automating repetitive tasks in Unix Linux operating systems. It involves writing script sequences of commands saved in a file that the shell can execute as a program. The shell is a command line interpreter that provides a user interface for the Unix Linux operating system. Shell scripts can perform various tasks like file manipulation, program execution, and printing text. What can you expect in the shell scripting interview? Senior DevOps positions require high proficiency in Bash scripting, essential for automating routine tasks, configuring systems, and managing deployments in Unix Linux environments. Candidates should demonstrate their ability to write clean, efficient, and maintainable scripts to handle complex tasks. This includes leveraging Bash-specific features like arrays, functions, and conditionals, and integrating with other command line tools and languages like Python or Perl for more complex operations. Performance optimization. Optimizing the performance of systems and applications is paramount in DevOps. Candidates should understand the performance metrics and monitoring tools available in Unix Linux systems. To improve overall efficiency, they should be adept at diagnosing performance issues and implementing optimization strategies, such as script optimization, system resource management, and tuning server configurations. Unix Linux system interaction. A comprehensive knowledge of Unix Linux systems is a cornerstone for senior DevOps roles. This encompasses a thorough understanding of the operating system's architecture, command line utilities, file system structure, process management, and networking. Candidates are expected to easily navigate these systems, employing Bash scripts to interact with and manipulate the system at a granular level. This includes automating system maintenance tasks, configuring network services, and ensuring system security through proper setup and management of permissions and access controls. Problem-solving skills. Problem-solving is at the heart of DevOps. Candidates should quickly identify issues within scripts or systems and devise effective solutions. This involves troubleshooting scripts, resolving system errors, and debugging performance bottlenecks. Senior DevOps engineers often face unique challenges requiring creative and efficient solutions. Hence, a strong problem-solving ability and a deep understanding of system internals and scripting nuances are crucial. Best practices and tools integration. Familiarity with best practices in Bash scripting and DevOps is essential. This includes writing readable and reusable code, understanding and implementing error handling, and integrating version control systems like Git into the scripting workflow. Candidates should also be familiar with integrating Bash scripts with other DevOps tools such as Jenkins for CI/CD, Ansible for configuration management, and monitoring tools like Nagios or Prometheus for real-time system monitoring. Collaboration and continuous improvement. Senior DevOps roles require technical proficiency and strong collaboration skills. Candidates should demonstrate their ability to work within a team, share knowledge, and continuously seek to improve processes and tools. This includes staying updated on the latest developments in scripting and DevOps methodologies and being open to adopting new tools and practices that enhance productivity and system reliability. The next tool is Python. What is Python for DevOps? Python for DevOps refers to using Python, a versatile and widely used programming language within the practices and processes of DevOps. DevOps is a set of practices aimed at unifying software development dev and software operation ops, emphasizing automation and monitoring at all steps of software construction, from integration, testing, releasing, deployment, and infrastructure management. DevOps aims to shorten the development lifecycle, increase deployment frequency, and achieve more dependable releases closely aligned with business objectives. What can you expect in the Python interview? Optimizing the performance of systems and applications is critical in DevOps. With Python, candidates should understand how to use profiling tools such as cprofile and timeit to measure script performance and identify bottlenecks. They must also be skilled in applying optimization techniques, including efficient algorithm selection, concurrency with threading or async I/O, and leveraging C extensions for intensive tasks to enhance script and system performance. Unix Linux system interaction. A deep understanding of Unix Linux systems is fundamental for senior DevOps roles. Python scripts can be employed to interact with and manipulate the system extensively. Knowledge of Python's OSs and subprocess modules, among others, enables candidates to automate system maintenance tasks, configure network services, and manage system security. This encompasses writing scripts that interact directly with the system's file structure, process management, and networking capabilities. Problem-solving skills. Problem-solving is crucial in DevOps. Candidates must identify and resolve issues within Python scripts or the wider system. This involves troubleshooting system error resolution and debugging performance issues. Python's extensive debugging and logging tools like PDB and logging support this requirement. Senior DevOps engineers should be capable of addressing unique challenges with innovative Python-based solutions. best practices and tools integration. Understanding and applying best practices in Python scripting and DevOps are key. This includes writing readable and reusable Python code, implementing robust error handling, and integrating version control systems like Git. Familiarity with integrating Python scripts with DevOps tools such as Jenkins for CI/CD pipelines, Ansible for configuration management, and Python-based monitoring tools example using Apache to interact with Prometheus or Nagios are essential aspects of the role. Collaboration and continuous improvement. Senior DevOps positions necessitate technical proficiency in Python and strong collaboration skills. Candidates should demonstrate their ability to work effectively within a team, share Python-related knowledge, and continuously seek to enhance processes and tools. This involves staying abreast of the latest Python developments and DevOps methodologies and being open to adopting new tools and practices to improve productivity and system reliability. What is Amazon Web Service? Amazon Web Services is a comprehensive and widely adopted cloud platform offered by Amazon. It provides over 200 plus fully featured services from data centers globally. Amazon Web Service enables individuals, companies, and governments to leverage robust computing infrastructure, storage solutions, and various platforms for development, analytics, machine learning, security, and much more on a pay-as-you-go pricing model. What can you expect in the Amazon Web Service interview? For senior engineers, interviews centered around Amazon Web Service often explore complex scenarios that test a candidate's depth of expertise in architecting solutions, optimizing performance, enhancing security, managing costs effectively, and troubleshooting within the complex Amazon Web Service ecosystem. Interviewers aim to evaluate not only the candidate's technical proficiency with Amazon Web Service services and tools, but also their ability to design robust, scalable, and secure systems that align with business objectives and operational requirements. High availability and fault tolerance. Questions may probe into the candidate's experience designing highly available and fault-tolerant systems across multiple Amazon Web Service regions and availability zones, requiring a deep understanding of Amazon Web Service global infrastructure and services like Elastic Compute Cloud, Simple Storage Service, Relational Database Service, and Virtual Private Cloud. They might also explore how candidates optimize resource utilization and application performance using services like CloudFront, Autoscaling, and Lambda, alongside monitoring and management tools like CloudWatch and CloudFormation. Security and cost optimization. Security is another critical area, with discussions covering strategies for safeguarding applications and data against threats, using Amazon Web Service Identity and Identity Access Management, Cognito, Key Management Service, and Shield. Additionally, candidates might be asked to articulate their approaches to cost optimization, including using Cost Explorer and reserved instances to ensure efficient resource allocation and expenditure. Troubleshooting skills. Troubleshooting scenarios can further reveal a candidate's problem-solving skills and proficiency in navigating the Amazon Web Service environment to diagnose and resolve issues swiftly. These scenarios might include addressing deployment challenges, network connectivity issues, database performance bottlenecks, and security vulnerabilities. Continuous learning and improvement. Moreover, interviewers are likely interested in how candidates stay up to date on the latest Amazon Web Service features and best practices, and how they contribute to a culture of continuous learning and improvement within their teams. This might involve discussing participation in Amazon Web Service workshops and seminars, certifications, and contributions to professional forums and communities. In conclusion, senior engineer interviews for Amazon Web Service roles are designed to gauge a candidate's comprehensive knowledge of the Amazon Web Service platform, practical experience in leveraging Amazon Web Service to build and manage sophisticated solutions, and capability to lead and innovate in a fast-paced, ever-evolving cloud computing landscape. Candidates are expected to demonstrate their technical insight, strategic thinking, leadership qualities, and commitment to excellence. What is Jenkins? Jenkins is an open source automation server widely used in DevOps and software development for continuous integration and continuous delivery. It facilitates the automation of building, testing, and deploying software, making it easier for developers to integrate changes to the project and for users to obtain a fresh build. Jenkins supports various automation tasks, making it a versatile tool for DevOps practices. What can you expect in the Jenkins interview? Regarding senior positions in DevOps, the expectations significantly shift towards a deeper understanding of Jenkins, one of the most widely used automation servers for continuous integration and continuous delivery. This includes an in-depth knowledge of Jenkins's complex features, best practices, and ecosystem. Jenkins pipeline and Jenkins file. Conceptual understanding. Be ready to explain the Jenkins pipeline and its significance in continuous integration and continuous delivery processes. Practical application. Demonstrating practical skills in writing and managing Jenkins files for declarative and scripted pipelines. Interview preparation tips. Scenario-based questions. Be prepared for scenario-based questions where you might need to design a pipeline for a given application stack or troubleshoot a failing build. Practical demonstrations. Some interviews may require live coding or practical demonstrations of Jenkins file writing or plugin configuration. Tool integration. Expect questions on integrating Jenkins with other continuous integration and continuous delivery and development tools, showcasing a holistic approach to automation. Best practices discussion. Be ready to discuss continuous integration and continuous delivery best practices, primarily how they can be implemented and enforced through Jenkins. Security measures. Understand Jenkins security concepts, including credentials management, securing the Jenkins master, and using access controls. Experience sharing. Be prepared to share experiences from past projects, particularly challenges faced, and how you leverage Jenkins to address them. Advanced features and best practices. Complex features. Senior professionals should be adept at leveraging Jenkins' advanced features like parameterized builds for triggering builds with different parameters, matrix builds to run the same build job across multiple environments, shared libraries for reusing code across multiple pipeline scripts. Best practices. Implementing continuous integration and continuous delivery best practices with Jenkins involves keeping Jenkins and plugins updated to leverage new features and security fixes, using multi-branch pipelines and webhooks for automated triggering of builds, segregating builds into smaller, manageable units for faster feedback loops, implementing proper error handling and notifications within the pipeline, plugins and integration, plugin management. An understanding of critical Jenkins plugins is crucial. This includes knowing how to select, install, and maintain plugins that extend Jenkins for various tasks like integration with version control systems, build tools, testing frameworks, and deployment environments. Tool integration. Senior roles often require integrating Jenkins with various development, testing, and deployment tools. This includes source control tools Git SVN, build tools Maven Gradle, containerization and orchestration Docker Kubernetes, monitoring and analytics tools, troubleshooting and optimization. Troubleshooting, diagnosing and resolving issues with Jenkins, including performance bottlenecks, build failures, plugin conflicts, and security vulnerabilities. This also involves tuning Jenkins for optimal performance and scalability and ensuring high availability and disaster recovery. Security, implementing and maintaining security best practices, such as configuring Jenkins within a secure network, managing credentials securely, and setting up proper access controls. For senior positions, expertise in Jenkins goes beyond merely setting up jobs. It encompasses designing and managing complex continuous integration and continuous delivery pipelines, optimizing workflows, integrating with a broad ecosystem of development tools, and ensuring the security and robustness of the Jenkins infrastructure. Mastery over Jenkins file and plugin. Management and the ability to troubleshoot and optimize Jenkins installations are key expectations that underscore Jenkins's critical role in modern DevOps practices. What is Ansible? Ansible is an open source automation tool or platform for configuration management, application deployment, orchestration, and provisioning tasks. It aims to provide a simple yet powerful automation solution for managing complex deployments and environments. What can you expect in the Ansible interview? For a senior engineer, interviews often delve into a candidate's deep knowledge of Ansible's capabilities, emphasizing their familiarity with basic operations and understanding of more sophisticated features. This exploration assesses the candidate's ability to utilize Ansible's full potential in managing complex automation tasks, evaluating best practices, and complex workflow management. Interviewers are particularly interested in a candidate's experience with best practices in Ansible usage, including playbook optimization, role creation, and inventory management. The ability to design and implement efficient, scalable, and maintainable automation workflows using Ansible is a critical skill set for a senior engineer role. Strategic approach to automation with Ansible. A significant part of the interview process involves discussing the candidate's strategic approach to using Ansible for configuration management, application deployment, and orchestration. The focus is on how these strategies contribute to creating automated environments that are robust, scalable, and easy to maintain. Proficiency with dynamic inventories and customization. The discussion often extends to the candidate's proficiency in leveraging dynamic inventories for real-time infrastructure management and using Ansible's extensive module library for various automation tasks. Additionally, the ability to customize Ansible roles for code reusability and organization is a marker of the candidate's deep understanding of Ansible's architecture and capabilities. Introduction to monitoring in DevOps. Monitoring plays a pivotal role in the DevOps ecosystem, serving as the backbone for ensuring optimal performance and reliability of both applications and infrastructure. Monitoring provides the critical insights needed for proactive decision making and operational excellence in the rapidly evolving landscape of software development and IT operations. Here's an overview of what monitoring entails in DevOps and why it's indispensable. What can you expect in the monitoring interview? For senior DevOps professionals, the ability to design, implement, and manage sophisticated monitoring solutions is a requirement to guarantee the reliability, performance, and security of applications and infrastructure. In the ever evolving landscape of technology, where complexity and dynamic environments are the norms, advanced monitoring strategies provide the insights needed for proactive management and decision making. Comprehensive visibility across systems. Ensuring end to end observability. A senior DevOps engineer must prioritize establishing a monitoring framework that provides end to end visibility across all technology stack components. This includes everything from low level infrastructure metrics to high level application performance indicators. DevOps professionals can gain a holistic view of their system's health and performance by integrating tools that monitor physical, virtual, and cloud based infrastructure alongside application performance monitoring solutions. Real time alerting and anomaly detection. Implementing intelligent alerting systems. An advanced monitoring setup must include real time alerting capabilities that are both accurate and actionable. Senior DevOps practitioners should leverage machine learning and statistical analysis to distinguish between normal fluctuations and genuine anomalies. Configuring alerts based on dynamic thresholds and patterns of anomalies rather than static values helps reduce noise and focus on issues that genuinely require attention. Automated response and remediation. Enabling automated remediation. Senior DevOps roles involve setting up automated response mechanisms beyond detecting and alerting on issues. Using tools that support auto remediation scripts or integrating with orchestration platforms enables the immediate and automated resolution of common issues, thereby increasing efficiency and minimizing downtime. Performance optimization. Focusing on continuous optimization. Monitoring should be about detecting and reacting to issues and continuous improvement. Senior DevOps professionals must analyze monitoring data to identify performance bottlenecks, inefficient resource usage, and opportunities for optimization. Implementing regular performance testing and baselining as part of the monitoring strategy ensures that systems are always running optimally. Security and compliance monitoring. Ensuring security posture and compliance. With the increasing emphasis on cybersecurity, monitoring solutions must extend to security. Integrating security information and event management tools, vulnerability scanners, and compliance monitoring solutions into the DevOps workflow allows for the continuous assessment of security posture and compliance with regulatory standards. Custom metrics and logs. Leveraging custom metrics and log analytics. While standard metrics provide significant insights, custom metrics specific to an application's or infrastructure's unique aspects are often needed to understand its behavior fully. Senior DevOps professionals should implement custom metric collection and log aggregation capabilities. utilizing log analytics tools to parse, analyze, and visualize logs for deeper insights. Cloud native and microservices monitoring. Adapting to cloud native architectures. In cloud native and microservices architectures, more than traditional monitoring approaches might be required due to the dynamic and ephemeral nature of containers and microservices. Implementing monitoring solutions designed for container orchestration platforms like Kubernetes, which can handle service discovery, scaling, and the ephemeral nature of containers, is crucial. Collaborative incident management, fostering a culture of collaboration. Finally, an advanced monitoring solution should promote collaboration across development, operations, and security teams. Integrating monitoring tools with communication platforms and incident management solutions ensures that the right people are notified and can collaborate effectively to resolve issues swiftly. Obviously, there are still many tools in the DevOps space that I still need to cover. Please let me know if you want me to cover them in a future video. Thank you everyone for watching the video. If you liked it, please don't forget to subscribe to the channel. For more content like this, check out my book, Cracking the DevOps Interview. You can find the link in the description below.